Sound check, 1, 2, 3. How's my audio, everybody? Good morning, happy Saturday. It's like the old days in Saturday morning when everyone would wake up and gather around the television tube, not the YouTube, and watch cartoons. And now you're all here gathered around the YouTube and watching the coding train. It's very weird to be here on a Saturday. Especially in the morning. I don't think I've ever I've probably streamed on a Saturday before. I don't know that I've streamed on a Saturday morning before. This isn't a particularly great time. I mean, there's something about this time that's actually quite nice. I feel sort of relaxed and a bit at ease, and very glad to be here. But also, you know, the weekend is the weekend, and there's lots of family stuff and other things going on. So I don't know that I'll be making a habit of this. But here we are, nonetheless. Welcome. It's so nice to see so many people here. I don't actually see you, but I feel your presence. I feel more calm today for some strange reason. Maybe it's because I ran the marathon last weekend. And I have a very particular topic that I want to focus on today. Just quickly before I go with that topic, I want to just thank the sponsors today for Saturday's Coding Train live stream, which are Dashlane and Linode. So if you go to dashlane.com/codingtrain or linode.com/codingtrain, you can find out about both of these web services, Dashlane as a password manager and Linode as a cloud server. And I'll come back in the middle of the live stream and talk to you a bit more about the sponsors and show you some clips and features that they have, and tell you about the coupon codes. Okay, so console log hello world, says Cybertron. Hello, Cybertron. It is, but still a bit low. And Nathan in the chat is okay. So Nathan is a very loyal viewer who has really been getting at me to do some upgrading of the audio equipment that I have is actually quite good, I believe. I have a lav mic here. I actually have a shotgun mic over there that I don't use. But what I really need to do is some fine-tuning of the audio. I use a piece of software called Open Broadcast Studio. Let me actually check. I don't believe I'm recording anything to disk right now. I'm going to add that. Oh, it's right here. I'm going to hit start recording. And the focus is also not on point. You know, I'm out of practice here. It's Saturday morning, and I'm just like, what's going on? I should be at home having brunch and reading a nice magazine or book and listening to some jazz music on the radio. I'm going to use this, not a sponsor, but one of my favorite products called the Elgato Stream Deck, which is my tool for focusing, because I put it over there, and then I walk over to the camera, and I focus on it. There we go. I think that's, problem is my eyesight is actually quite bad, so I can't even see. Good enough. I think that's better. All right, so one thing I want to mention today, if you have been paying attention to the Coding Train YouTube channel, you would be aware of this. But if you're not, if you go to thecodingtrain.com/TM for Teachable Machine, it will take you to a web page which has 3 videos that actually 2 videos that I released this week and one that's still sitting on the channel as unlisted. Other people are asking for the audio to be a little bit louder. I'm always afraid to turn it up because I'm just worried about it peaking, but everybody is telling me that it could be louder. So let me go. I have a little dial. Here's this little dial. I see it here. It says gain on it. It's on this audio interface. It's blinking green, and if I just turn it a little bit to the right, I have now made myself a little bit louder, I think. And I see it's in the yellow, but not in the red. The problem is I get very excited sometimes when I'm live streaming, and then it starts going into the red. But Teachable Machine is a project from Google Creative Lab that I've referred to in a lot of my ml5.js videos. And but they released a new version of it. If I go to teachablemachinewithgoogle.com, I will be on this web page, and it is a fast and easy way to create machine learning models for your sites, apps, and more. No expertise or coding required. And you can see that. So I'm not going to go through this right now because I have 3 videos that go through it in quite a bit of detail. But I encourage you to check out the video about it. They actually have their own tutorials that you can watch that are much more succinct, not as insane as mine. So I don't know what your preference is, but if you just want to learn how it works, I would definitely recommend you watch theirs instead of mine. If you want to watch somebody embarrass themselves for 15 or 20 minutes, then you can watch mine. Some wonderful projects, and one of the things I'm very excited about is how they've integrated the Teachable machine learning models with all these other libraries and frameworks, in particular the P5.js library with the ml5 library. So I don't want to go through this now. It really relates to what I do want to do in this session, which is look at a particular feature of the ml5 library that it also deals with training a model. But I would encourage you to check out my videos, and in particular, I would really love to see what people make with this. I mean, I love that for everything, but I'm particularly curious as to whether this methodology of working, this interface in the browser that allows you to train a model and then download that model or export or upload that model to work with, say, P5.js and ML5, if that's something that inspires people to make creative work. And so for any of these videos, if you click on this to the tutorial button, and there's actually, one of them you'll see there's this area called community contributions, and I want to see your community contributions here so badly. So please, because I would like to come back and look at some of them and play with them on a future video. There was one. So I think if I go to maybe the snake game, yes. So Mika Krushel, who has been a wonderful supporter of the channel in contributions on GitHub, thank you so much for adding a lot of stuff to the website and things. I really appreciate that. This is the only community contribution that I know of. So let's try it. And one of the things that's really interesting about this system is if you train the model, say, using your webcam, it's going to learn the context of what your webcam is looking at. So let's say you train it to recognize a banana versus an orange. Would that still work when I look at it here in this context with the green screen behind me? All right, so here I am loading. There we go. So I think the idea here is that I'm supposed to play rock, paper, scissors with the computer. I guess the computer is just winning. Oh no, I won. I guess it's actually detecting that I did scissors. Or I'm going to do paper. It detected my paper. That's awesome. Of course, I lost. Paper again, I win. Let's see, does it detect rock? Hold on. There we go. Thinks that's scissors. Thinks that's paper. So a couple of things I would say here is that interaction design-wise, just as a little critique here, Mika, I'm kind of confused. So what I think I understand is that's what the computer's picking, and that's what I'm picking. But what I'm really confused here is about the timing. So I feel there is this like ready, but I feel like what might be helpful is some sort of like countdown timer, like get into position, because when you play, one way to play the game is rock, paper, scissors, says shoot, like that kind of thing. So I wonder if there's some kind of way that it could step me through the process a bit more. And maybe the visual language of this being bigger is meaningful, and the emojis as like what's the computer versus me are also, I think, quite effective. But something about the difference in sizes and the placement, I like that the video is there but kind of faded into the background. That's kind of, I think, a nice idea. But I think maybe there could be some other ways to think about how to do the interface. I also am really lost in finding myself because I think this is cropped, and I would mirror the video because it just makes interacting with things much easier. Because oh no, it is mirrored. It is mirrored. It's definitely mirrored. I just was, oh, I see. Maybe it's doing that on purpose so that if I put, so that there we go. I see. This is what it wants me to do. So maybe there could be a bit of a stage where it lets you kind of get set, and it seems there's a moment also where it's like freezing. And I find that very distracting. So I kind of want to see it always. Great. So I want to see more of these. Oh, Mika's in the chat. The timer is the pink bar at the top. Okay. Got it. I see. I see. And Simon is saying that there have been a bunch of community contributions from the interactive drawing video. So maybe I will. Let's go take a quick peek at that. Oh, one thing I need to do. So I have this iPad here where I can play, and the Collatz Conjecture. Okay, everybody, settle down, settle down. It only has 2% battery left. So I'm going to unplug it and go plug it in over here. So I won't have any music for a little while. Let me let this charge up. But it'll charge up by hopefully the time that I need the music. All right, let's check out what else is happening on the channel here. There's the interactive drawing was one of a recent video that I can take a look at. And also the Collatz Conjecture. I haven't had the time to do another one of these Cabana videos, which I'm very sad about. Ironically, I probably would have done one this morning if I wasn't coming here to do this live stream, but too many things to do. Okay, I don't see any community contributions for this one yet. I'm shocked. I'm shocked. I'm shocked. Add your community contribution for this video. Let's check out the Collatz Conjecture. There definitely have been a bunch. Whoa, there's a lot. Amazing. Let me just do a quick click through. I'm just going to open them all up. This one, for some reason, doesn't have a link. Let's open that. This is probably a bad idea what I'm doing. Let's just look through these. Okay. Of course, little rainbow Collatz Conjecture visualization. Gotta love that. This is by Sequential Chaos. Now we've got one that is by Alvaraco. Looks pretty similar to mine, but there's probably something different here that I'm not aware of. Let's see if it says. Growing visualization. Oh, no. This is not similar than mine. I made a version of this like this myself just to make a GIF to post on Twitter, but this one is actually animating it. I forgot that my video tutorial doesn't animate it, so that's wonderful. Thank you for that. Collatz tree. Refresh. Oh, sad. Where's the tree? Why is it showing me all this nonsense? Okay. So I'm not sure what's happening with this one. We can click on looking at the code and try running it here. Do I have to click? I probably have to click or something. Nope. So I'm not sure what's going on here. Danawi, let me know. I'm happy to try showing it again. This is a Collatz visualization from a spectral flame. Added code for animated and static drawing. So one thing I certainly recommend, if you can, let's see, is to add a README file with like a GIF animation or a screenshot that scroll down the page, says Simon. Let me go back to that one. The Collatz growing tree. Okay, let's go back to it. Ah! It was just taking up a lot of space. There it is, another growing one. And I like the color selection here, the green. This is a good Team Trees. If you haven't made your Team Trees donation, please go ahead and do that. Ooh, here's a really nice, look at this one. I like this from Superembo. Ooh, this is Collatz Sunrise from Anurag Hazra. This is quite lovely. I saw this on Twitter. And a lot of people had sort of fun names for this kind of supernova-like design. And I like this use of dat GUI here. Looks like I could probably try changing various parameters. And I don't know if, oh, and then if I click, I guess it'll every time I click, it'll reset and rerun with these new parameters. I really want to do some more printing of these. And make some, so that's our plotter stuff. I gotta come back to that someday. This is lovely. Okay. Collatz weed. This is interesting. Again, another processing one. There's this. Now I really want to kind of run this. So I'm like, I guess to run one that's in processing, I have to just download it. And now if I'm going to do this, I should also go back to spectral flames because that's only fair. A lot of stuff in this downloads directory, but since there's a fish, I got to know what this fish is. Oh, look at that! I love this. So I love this. What I love about this, which surprises me in a way, is using, I suppose, this Collatz conjecture visualization in a scene. So you could imagine this being a 2D game that you're playing where you're moving, you're the fish and you're controlling the fish and the fish has to eat or swim or whatever. But all the while, little did you know, the trees at the seaweed at the bottom was all coming from the Collatz conjecture. Okay, let's, Collatz, click sea tree. I guess, so this looks like maybe it just picks a different angle and a color scheme each time, which is really, really nice. So nice to see these variations. Another rainbow one. Thank you, Luis de Leon. And we're seeing this also on CodePen, so it's nice to see people try different code editors and frameworks. Eric Rovell posted something about trying a 60-degree angle, and it looks like the image I'm seeing over here on my Slack chat screen is showing a very like hexagonal pattern, which is nice. I don't know if that's going to show up. Another one here, Garrulous Dash by Diplofocus. Oh wait, I think I made everything tiny. There we go. Ooh, I like this. I like this idea of these sort of like dash lines here. Spectral flame, we're going to try that. Let's try spectral flame. Let's get rid of this here. Oh, let's get rid of this here. And try this. Nope, that's the other one. Want this one. There we go. Ooh, I like this. I like the layering of this. Now, what's different? I guess it's doing huge sections at once and then varying the color and kind of blending it. It's quite, oh, wow. Oh, this is quite enjoyable. It needs some music. This needs full screen and music. I'm just going to let you enjoy this for a minute. Oh, I still have my mic on. I thought I muted my mic. I was taking a break there. I was giving myself a break. Thought I was muting my mic. You probably heard me sip some tea over there. Okay, I'm back. Hello. This is lovely. Ah, beautiful. Just beautiful. Okay. Refresh the repo. Oh, look at this. Here's a nice README. So listen, okay, the version of number file uses the angle of pi divided by 13 to the right and pi divided by 20 to the left. They have these long lines with bumps on the underside of them. Oh, okay, I think if I'm right, Spectral Flame, maybe you also commented in the actual YouTube video. Somebody wrote a really excellent commentary about somewhere that I read. It was on Twitter or in the YouTube video, or maybe it was, maybe this was the conversation we had on GitHub. But and maybe it was Spectral Flame. Apologies if it was somebody else who really did a sort of deep dive in figuring out what were the properties of the visualization from the number file video and how those were different from the ones that the version that I created. And it looks like there's a really nice explanation of that here. And played around with some more and got this colorful artwork. N equals, it's always hard to read, 5 million. Change the color palette to include all colors. Wow, look at that. That is quite something. Technique Collins is asking, where can I get the documentation for the Quick Draw project? So I'm not sure exactly what you're referring to, but if you're referring to the actual Quick Draw data set, that is also from Google Creative Lab, and there's a GitHub repo that has all of the documentation of the Quick Draw dataset. If you're looking for information related to my video tutorial that makes use of a machine learning model called SketchRNN, which was trained on the Quick Draw dataset, then you can find that at thecodingtrain.com if I go to the challenge page. And typically, I mean, sometimes things are missing here, and if they are, you can file an issue or actually submit the link. But all of the relevant links related to the material that I use should show up here. Other videos that are related should show up here, and then community contributions. But if you're looking for the code, you can find that here. And a lot of times, my goal is to always have JavaScript code, processing code, and a link to the version running in the web editor. But this one has no processing code because I don't currently have a Java. There's not an easy way to bring the SketchRNN model into Java. It's definitely possible, but it's not something that I've spent some time doing. By the way, I added this overlay thing. There haven't been any new members or anything joining yet. I'm just curious if something's going to pop up. So I didn't miss that, did I? Coding Train ask DT6, will you try Q learning in the near future? So I would answer yes to that question if we could take the word near out. I'm having a tough time. I'm definitely doing a lot and making content. And I made this list, and I actually don't have it. Simon probably has it handy somewhere at the beginning of the semester of kind of the things that I wanted to do this semester. And I've gotten to very few of them. I've definitely gotten to some of them, but I've gotten to very few of them. Q learning is on my list of things that I would like to tackle. It's not something that I have a lot of experience with. A researcher here at NYU named Ada Nelson has made a bunch of Q learning examples with P5. I can try to find those and link those. David Snyder. Well, it doesn't look like that overlay works. I would have to refund you your money. Thank you. Oh, well, that's sad. wonder what I need to do to get that to work. Oh well. There we go. Thanks. Simon is now sharing with me my list. I wonder if there's an easy way for me to pull that up on screen. And Dan Man asks, are you going to make videos about making our personal teachable machine framework? Okay, wait, let me cover this. And then some people are asking about whether the teachable machine, sorry, this was not a call to ask people to give super chats. I apologize. That was not really my intention. Thank you. Very generous of you, and it's very much appreciated. And I thought I had a little overlay thing that would pop people's names up or their messages, but apparently that didn't work. So I forgot about the questions. So many good questions. I'm trying to answer these. Okay, I'm gonna actually scroll the chat, which will stop it automatically scrolling. Okay, are you going to make videos about making our personal teachable machine framework? So I actually have. Well, look at all what an interesting that this pops up this weird. What I'm looking for is the YouTube playlist, but it's kind of interesting. I guess from the ML. This is the link that I'm looking for. Apologies. Oh no. I want the playlist though. Oh, the internet is a rough place. Why don't I have this playlist linked in an obvious place? Let's try. What's the chance it's on like one of these? Probably not. Website, working on the website. No. An issue to GitHub so I can pull up. Thank you. That's an excellent way of doing this. I have a lot of content, but I guess I have to do what I didn't want to do, which is actually just go to my channel. How are there 447 people watching this right now? And look for playlists. Oh my God. You know it's bad when I can't even, look at this, private liked videos. I don't want that to show up. I didn't even think I was, I'm logged into my main account. That's not my intention. Oh God, this is not going well. Created playlists. What I'm looking for is, it's gonna happen for me. Begin. Oh, there it is, I found it. That's very sad. The question was, are you going to make videos about making our own personal teachable machine framework? If you want to do that, you can do that with the discussion in my ML5 video about transfer learning with the feature extractor and then running your own feature extractor classification example. This is basically a bit more that's in terms of the technical material that you would need to actually create the training interface and control the training process yourself more closely. So sorry that took me a long time to pull that up. And what I want to do today is actually make content, to go through a bunch of examples in this live session that will get edited down into videos that will end up in this playlist about training a neural network model. All right, so the other questions were, the teachable machine exports are currently broken. Is that being looked into? I don't know. I do know that there is a little bit of a source of confusion. A bunch of people posted that they had an error, like a fetch error. And maybe I can just touch on that really briefly. So if I were, let's just pretend for a second that I just trained a model, and I went here to export model. There's no model trained. So you're going to get, once you've gone through this whole process, you're going to get a URL that's here. And then you're going to see here, you're also going to see a code snippet. What's confusing is the URL that Teachable Machine gives you does not include, it's just the path to all the model file, but it does not include model.json, which ML5 expects. So if you were copying and pasting,
I'm having trouble hearing you.
yeah, thanks. I can tell. If you're copying and pasting this code, the URL that you have for the model, that gets stored in a variable, and then you have to append model.json for it. I was seeing people have that error. There's a YouTube problem with emotes on streams. Spamming like 10 emotes can get your Google account suspended. All right. So those were some questions that I wanted to answer. I think I better get started with some content. It's already 11 o'clock, and I'm going to do my sponsor segment at around 11:30. I'm going to travel back in time. So someone keep me on track here. And I think this is going to go until 12 or 12:30. I mean, at this point, most likely 12:30. OK. How's that? Let me see how my... Oh, and let's go to the, since I asked for it, let's pull up what github.com/website. What is wrong with me? Coding train /website, issues, and to-do list. OK. Oh, wow. So this is my, let's do a little accounting here. RDP, done. Mara Rose, done. Collatz Conjecture, done. None of these, done. We could add, by the way, team trees, edited version. I don't know if it makes sense to edit that into something. That's sort of a discussion I have with Mathieu. So this is what I'm going to do today. Excellent. I sort of did this, but through making the video tutorial, we discovered a lot of problems with the library and it changed, so I need to redo this tutorial. I did this. I haven't done any of these. Oktoberfest is over. Streaming improvements. Nightbot. It says Nikebot. This should say Nightbot, I believe. Discord, and then 2020. So this is stuff for 2020. OK. All right, so this is good. I'm not doing terribly. The latent space stuff I'm really excited to do with Runway ML, so I have some plans for that. This I definitely want to do. This is a collaboration with a YouTube channel called Practical Engineering, so I need to get back to Practical Engineering about that. And today's topic will be this. I don't think there'll be a coding challenge today. I'm looking at this. This would be fun to do. But today, this is today. ML5 neural network. OK, so let's see how the charge is going with this. %. Boy, that really didn't do very good. I guess I could try to keep it plugged in. Have anything that this could connect to? Not really. There's no plug close enough to here. All right. Just looking at my notes from my class, seeing where Okay, I think I'm going to do this stuff. So, in case you're wondering what I'm looking at, I'm teaching a course at NYU this semester called Introduction to Machine Learning for the Arts. And I've been preparing a lot of material and doing a lot of teaching in the course about it. And I haven't been able to keep my plan was to be making the videos for the course all semester long. And to some extent I've been doing that, but I got way behind. So I'm kind of going back to remind myself what I did in class and sort of deciding how that is going to feed into what I want to show in this particular set of videos. And so I think I'm ready to go. And the other thing I want to do, one upgrade I've made to my recording system is that I have a way, and I'm about to turn this on, of recording all the different feeds to disk separately. The green screen, the laptop screen, and the whiteboard. And so this, if I'm going to edit, when I say if Mathieu, who is the video editor for the Coding Train, is going to edit all this stuff together, it's actually really helpful to have all these as separate things in case we want to add some more content and fix some things up. Okay, so I'm just looking in the set. So I need to record output. Oh, shoot, sorry. Give me a second here. Apologies to everyone that I'm doing this during the stream, but okay, wait. No. Okay. So output 2 is the whiteboard. Output 3 is the green screen. Output 4 is the laptop. And so if I go to my multi-quarter and I say I want 2, 3, and 4, now I'm going to start recording, and I'm recording everything. Okay. All right. So I'm trying to think of how I want to go about this. Because the nice thing, this is good and bad. The good news is I have more possibilities for creating higher quality edited versions of the live stream later, because I now have the capability to, even if I'm showing you things and talking about stuff during the live stream, I can replace the background with different content or more zoomed in and highlighted content, or even other animations and other things. So I could mention something, not even show it, and then show it later. So that's the good news. The bad news for you is that I don't want to fall in the trap of then just not ever showing anything in the live stream. And I don't want to also make the process of editing and putting together the videos so onerous that it becomes so slow. I'm also getting a lot of feedback from my monitor. So let me just mute this. Okay, great. Okay, so what I'm going to talk about today is the ml5 neural network class. Hello and welcome to another beginner's guide to machine learning with ml5.js video. In this video, I am going to look at a piece of functionality in the ml5 library called, I just heard a weird noise outside the room. I also hate that this light reflects in my glasses. I hear, by the way, I don't know if anybody's from the film industry, but I hear that often actors or performers in films will get these special non-reflective glasses, because this is a common issue. Obviously, if I had the lights above me or something, that could also get around this issue. So is that a thing? Because I'll go and buy those. I could go get new. I need new glasses anyway. I need a new prescription. Oh, spectral piano is off, I suppose. Okay. Whirly noise. I really want to do that whirly noise stuff. Also, should add to this list not the Mara rose, the star rose maybe. Okay. Hello and welcome to another beginner's guide to machine learning video tutorial with ml5.js. Very excited about this one. I'm typically excited about the video tutorials I make, but this one I'm particularly excited about because I'm going to look at something that has recently arrived in the ml5.js library. So first of all, use version 0.4.2 or a more recent version perhaps, but that's the version I'll be using in this video. And I want to look at this functionality in the ml5 library called ml5.neuralNetwork. It is a function in ML5 that creates a empty or blank, so to speak, neural network. Most everything that I've showed you in this video series so far has involved loading a pre-trained model. So a neural network architecture that's already been trained with some data. And in this video, I want to look at making an empty, a blank slate, configuring a neural network, collecting data, training the model, and doing inference. And the context that I want to look at that is with real-time interactive data. So I am going to come back and maybe use some more traditional data sets. There's a data set that's on the ML5 examples with the Titanic survival data set. I have the data set from my color classifier series. So I'll come back and show you some examples of those as well. But in this first video, I just want to do something very generic, which is create a blank neural network, use mouse clicks to train it, and then move the mouse around for it to make guesses or predictions. And that might sound like a weird thing to do, but hopefully it'll start to make sense as I build the code and step through all the processes. All right, so that was my beginning opening discussion. I did exactly what I thought is sort of a problem, which is that I didn't show you anything, like I didn't like click and browse around the website and find the stuff, but I do want to add that in later. We'll see how that works. All right. I do see that there is a suggestion about the audio context in JavaScript. It won't be happening today. I appreciate everyone's enthusiasm and wanting to have their ideas shown or talked about, but I'm on a particular path and I'm just doing the topic that I'm doing. And yeah, absolutely, computational geometry is on my list. Anti-reflective coatings applied on their glasses. I thought I had that, but I will get it. I'm going to go get new glasses. It's another thing for my upgrading my, how bad is the reflection right now? Because there is a way that I can turn the light away from me. And if you watch the Teachable Machine series, the third video has the light turned away from me and it doesn't reflect, but then I also have this weird shadow on my face. I don't know. All right. So I'm going to go to this page. Ooh, so this shouldn't say currently in development because it's definitely here. I'm just going to sort of scroll it down. I want to talk about Rebecca Feebrink and Wekinator. So let me talk about that. All right. The reflection doesn't bother at all. Okay. All right, so. I also want to highlight for you the Wekinator project, which is a free open source piece of software created by Rebecca Feebrink in 2009 for training machine learning models. And I would especially encourage you to watch Rebecca Feebrink's talk from the I/O conference in 2018, where she talks about creativity and inclusion in machine learning and goes through some demonstrations with Wekinator and processing and other pieces of software. So a lot of the work that I'm doing with ML5 is entirely based on recreations of many of the example demonstrations that Rebecca Feebrink made and has done research about for years and years with the Wekinator project. So in fact, the examples that I'm going to make in this video and the next one and the next follow-ups are direct ports, in a way, of some of the original Wekinator and processing examples. But I'm going to do it all in JavaScript in the browser with P5 and the ml5.js library. And I think what I'll say also is, there's also a fairly lengthy history of creative artists using real-time, training machine learning models in real time. Let me say that again. There's also a fairly lengthy history of creative artists training machine learning models in real time to control musical instruments, a performance, a visual art piece. And I would encourage you to check out some of these projects. Martlet by Michelle Nagai, From the Waters by Anne Hedge, This Is Not a Theremin by Guillermo Montesinos and Sofia Suazo, and The Eye Conductor by Andreas Resgard, that I will link to in this video's description for inspiration and ideas. Okay. So now, though, let's see here. Let me just quickly go to the getting started, copy this. I just want to get the library in the P5 sketch. Okay, there we go. And how am I on time? 11:20, all right. C'est la vie. Am I like, I don't think this camera is particularly level, but it's fine, right? You can, oh, let me check the focus at least. How's this whiteboard shot? Can you see that? How's the focus? Can't tell if I should, I'm afraid to touch this camera. It's very loosely mounted to the wall. Let me see. I can make it a little sharper. I think that's better. I think I just improved it. Okay, I should, well, never mind. Okay. Yes, I'm going to definitely refer to my former explanations about neural networks in general. Thank you, Peter. Okay. Our guide for figuring out how to write the code is going to be the ml5 website. And there's a page on the ml5 website for the neural network function. But before I start diving into the code, let's take a minute to talk about what a neural network is. Now, by no means am I going to be comprehensive about this at this moment. In fact, I'm going to give you a very zoomed out high-level overview, and I would refer you to the 3 Blue 1 Brown video series, What is a Neural Network, which is one of the most excellent videos on the internet to succinctly explain in great depth what a neural network is. And I have gone through many different playlists. I guess I should be doing this in front of the green screen in case you want to show any of this stuff. Oh, well, yeah. Let me just do it over here. I'm just going to say this again. Now, by no means am I going to give you a comprehensive explanation. Now, by no means in this video am I going to do a comprehensive deep dive into what a neural network is and how to code one from scratch. I will refer you to many other wonderful resources where you could do that deep dive, starting with the 3 Blue 1 Brown video, What is a Neural Network, and some of the subsequent ones. I have a 10 to 15 part video series where I build a neural network from scratch in JavaScript based on a particular book called Make Your Own Neural Network that is in Python. I have other videos that are guides around machine learning concepts where I talk about different kinds of neural networks. So I will link to all of those in this video's description, but here I'm going to use the whiteboard over here just to give you a very zoomed out, high-level overview of what I'm talking about. So a machine learning system, in the most basic sense, involves inputs and outputs. So we know a classic example of a data science approach to machine learning might be we want to have some sort of machine learning model that can predict the price of a house based on some set of factors. So it might be, the inputs in this case might be the number of bedrooms and the latitude and longitude of where it is in the world and the number of square footage or square meters, the size of that house. Those inputs would be fed into the machine learning model and the output would be a number, a price. This, by the way, is called a regression, which sounds like a sort of terrifying term. I have to be a PhD in statistics to understand regression. But what I mean in this case, a regression is the output is some continuous number. It's a price. It could be 0, it could be 100, it could be 1.5 million. It's some number, which is different than the output being a classification, meaning it is one of several categories. It's a cat, or a dog, or a turtle, or it's class A, or class B, or class C. So if you've watched my recent Teachable Machine video series about training an image classifier or a sound classifier, all of those examples are classification outputs. The output that you get is a set of confidence scores and categories. Interestingly enough, I started with this discussion saying I was going to give you a high-level overview of what a neural network is. And I haven't even begun that because I started talking about a high-level overview of the machine learning pipeline, the process. And so in a way, that's what this video is also about. And the way that I think might be an effective, an effective way that I might be able to demonstrate this to you is to find the most drop-dead, simple, almost trivial scenario to show you all of those pieces. Let me Yeah, this is just the corner of the room for people who are asking why. Oh, boy, something about the whiteboard today. It's very hard to erase. I need a whiteboard cleaning system. Okay. This marker's pretty bad also. Let's see if this one's better. Yeah, this one's better. So I will get to talking about what a neural network is, but for the moment, I'm actually going to stick with the sort of full pipeline of a machine learning project. I should really start this whole thing over. I don't like my explanation. But whatever. Let's just keep going. All right. I'm thinking, I know exactly what I want to do, but I'm just kind of confused about the sort of roundabout way that I'm doing this. So let's say for a moment that the goal that I have is to train a machine learning model to use my body as the input. So maybe how I'm moving my arms and legs and head, that will be the input. And the output would be a musical instrument, a note that's being played. So I could somehow play different notes based on how I move my body. This is a scenario that has been This is a scenario that Rebecca Fiebring covers in great detail in her course about machine learning and Wekinator. I forget what it's called. Machine learning for artists and musicians. This is a scenario that's covered in great detail in Rebecca Fiebring's course, Machine Learning for Artists and Creators. What? Musicians? No. How come I can't remember what that's called? The worst. Artists and musicians. Yeah, okay. I know you can't see it, but I'm recording it. This is a scenario that's covered in great detail in Rebecca Fiebrink's course, Machine Learning for Artists and Musicians. A very simple, one way that I might boil this idea down into its very simplest version is think about a 2D canvas. And it's very convenient that I'm using P5 because that's the thing that exists in P5.js. I have a 2D canvas. And what I'm going to do is I'm going to say there's a mouse in that canvas. And the mouse is going to move around the canvas, and based on where it is, it will play a particular note. Now, of course, I could do this with if statements very easily. And what's the thing that the Kyle McDonald quote? Kyle McDonald, I think I actually put it in my syllabus somewhere. It's in this talk, Weird Intelligence.
Raise your hand if you're interested in art.
It's a nice.
Where some people have, but it's in the heart to create something.
This is a really good talk, by the way.
Calling about an online request you once made about health.
This is great quote that I want to reference.
From the early using net file. I knew it was generated by the
I guess
production of the analysis and fit with.
I guess I missed it. Well,
sometimes I'd like to hard to create. Sometimes to define people are things like their record until.
I'm not going to find it. I'm going to give up. Okay. Where is that from? Shoot. Does anybody know what I'm talking about? Because I would like to reference it. Give me one more second to look for this. Kyle McDonald. What is machine learning? Yeah, this is what I'm looking for. Is it in this Medium article? I really like this explanation. I don't think I'm going to find it. I'm just going to have to say it in my own words instead of quoting Kyle. Maybe it was actually might actually have been a discussion here. Hold on. I know. Kyle. Oh, it's this one. It's this talk. Maybe. Or not. Okay, I give up. Sorry, everybody. So many things around the world to look at. Okay. All right, I give up. I give up. Sorry, I'm wasting way too much time. Go back to the if statement thing. Now, of course, I could program this same idea with an if statement, but this is really what it means to work with machine learning. Instead of programming the rules explicitly into code, what I'm going to do is give the code a whole bunch of examples and have it learn those rules. So I want to demonstrate that process in a scenario where it's very obvious how it's working, so that then we can build on that into much more complex scenarios where more sophisticated problems could be, or I guess really I'm just saying we could build on that into much more complex scenarios. Okay, so the steps are collect data, 2, train model, then 3, I guess we can call this prediction. So that's also sometimes referred to as inference. That's really when we're deploying the model, we're making use of the model. Right here, this is my representation of the model. I'm totally not talking about what a neural network is at all. So in this case, if I want to start with a classification problem, and I will show you demonstrations of classification and regression, I'm going to have 2 inputs, input 1 and input 2, often referred to as X's in a sort of machine learning context. Those inputs are going to go into this machine learning model. The output is going to be one of, let's say, 3 different categories. So I'm going to have 3 outputs, notes like A, B. Well, let's actually play a C major scale. The worst eraser ever. C, D, and E. So 2 inputs, and in this case, 3 outputs. My diagram is the weirdest looking thing ever. I hate the way it looks. It is 11:30, says David. Okay, I'm gonna get through this explanation, then I'll take a short break before I start with the coding. I feel like I'm not actually, there's no reason for me to explain. I'm really lost in like where I am in the world of like what people who will be coming to watch this will have seen before and what makes sense to explain and not explain. But I'm going to just keep pushing forward. Okay. Okay. My diagram looks a little bit weird, so I'm going to fix it up for a second. This is like the craziest thing I've ever done. But why not? Okay. Okay, so I have 2 inputs, input 0, input 1, and 3 outputs, C, D, or E. Now, all this time I've just been putting the word, now all this time I've just been putting the letters ML in here for machine learning, or maybe referring to this as a model, because in truth, other things, other kinds of algorithms, other types of ideas beyond a neural network could slot in here. But the ML5 generic blank machine learning model that you can train is a neural network one. So if I were to try to zoom into this for a moment, what I would actually see is something that looks something like this. I was doing so well. This is going to be a really nice sped up moment. A neural network is an interconnected set of nodes and at least a feed-forward multi-layered perceptron, which is what this is a network where all of the data flows in one direction. The inputs come in here, they get processed by, well, the inputs come in here. The inputs come in here and get fed into what's known as a hidden layer. They get processed by something called an activation function, and then they go out of the hidden layer into the output layer. So this is really a two-layer network. It has inputs and then two layers, a hidden layer and an output layer. And a hidden layer and an output layer. And all of these connections have weights to them, and they're like little dials that you can twist and turn to process the information in different ways. This is my zoomed in diagram of really what's going on in here. A neural network is a network of neurons. This is a feed-forward multi-layer perceptron, because the inputs, which are represented right here, get fed through these connections. They're weighted connections and get added up all together and arrive in this layer, which is known as the hidden layer. And there can be multiple hidden layers and different kinds of hidden layers, but the data is summed and processed through a mathematical function called an activation function, and then fed out of the hidden layer and into the output layer. And the output layer, after all of the hidden outputs are summed and passed through an activation function, we get a set of numbers out. And those numbers might look like this: 0.2, 0.7, 0.1, meaning there's a 2% likelihood that this was category C, a 70% likelihood that this was category D, and a 10% likelihood that this was category E. So there's a lot more details of what's going on in here, and I certainly, once again, would refer you to the various things that I'll link in this video's description. But the idea is that a neural network is a process that is a neural network is a kind of machine learning model that can be trained. All of these weights can be adjusted so that the idea here is that a neural network is a machine learning model that can be trained. It can be shown a lot of examples of inputs with their correct corresponding outputs, and it can tune all of the weights of all these connections so that when it later gets new data, it can make appropriate predictions. This is everything that the ML5 library will take care of for you. And for us, we're going to really just be working with the inputs and the outputs, collecting our training data, training the model, and predicting outputs. Thank you. Thank Thank you. All right. Finally, you got to the point. Messed up the percentage. What did I say? 2%? Did I say 2%? Re-record. A 20% chance of being category C, a 70% chance of being category D, or a 10% chance of being category E. Okay. All right. Thank you, everybody, for your patience. I said 7%? Oh, my God. It's only getting worse. Okay. Just checking my phone. It's 11:45. Got to move quicker here. All right, so I'm going to take a minute or two to thank. Whoops, hold on. Where am I? The sponsors of today's Coding Train. Oh, come on. And so I am going to start with Dashlane. So first of all, if you go to dashlane.com/codingtrain, that is the link you'll want to use to check out Dashlane. So here's the thing. If you are concerned at all about staying safe online, one of the things you really want to have in your tool set is a password manager. I could not possibly live without a password manager. And in fact, if I come back here to my screen right here, and if I were to say, if I were to log out of the web editor and just open it up and feel like I need to log back in, as you'll see here, I can log into my password manager Dashlane, which will then pull up my password for the web editor and get me logged in instantly. So it's the kind of thing that's like a real pain on the internet, is to memorize and keep track of all your passwords in a secure way. And one of the ways you really want to do, one of the things you really want to do is have a different randomly generated password for everything that you log into. And it's really hard to do that without a password manager. So when you create a Dashlane account, you get a single master password. It's never transmitted over the internet, not even to Dashlane and not to their servers. And when you generate a long and complex password for a new website in Dashlane, it's bundled up and encrypted using your master password that only you know. So you can see here just a whole lot of quick demonstrations of like logging in. There's generating a password. One of the things that I really also use that I find really super useful is just like having all of my like shipping information and credit card information, driver's license, social security number stuff, all saved in this very secure method that I can just quickly have. So if you want to try it out, you can sign up for free. You get a free 30-day trial of Dashlane Premium at dashlane.com/codingtrain. And then also if you purchase the premium account, you'll get a discount through the Coding Train as well. So now, in addition to a password manager, one of the things that I need very, very often is a web server. And so a new service that I've been experimenting with and looking at is Linode. So whether you're working on a personal project or managing your enterprise's infrastructure, I don't know, I don't manage an enterprise's infrastructure, maybe you do. Linode has the pricing support and scale you need to take your project to the next level. They've got 10 data centers worldwide, and they're launching an 11th in Sydney, Australia soon. So here's the thing. You, as a member, as a viewer of the Coding Train, can get a Linode account with $20 in credit today by going to linode.com/coding train. So you'll get access to native SSD storage, a 40 gigabyte network, and an industry-leading revamped cloud manager, which is built on an open source single page app cloud.linode.com. So you get root access to your server. You're going to see this right now. This is the kind of thing. So like my Twitter bot series, you could use Linode to like spin up your Twitter bot. You could do all sorts of things. It has one-click installs for WordPress and LampStack. You can have a Minecraft game server, all that kind of stuff. So just to quickly show you, if you go to linode.com/codingtrain, you'll get a nice welcome message for $20 credit for new subscribers from the Coding Train, and you can give this service a try out. And let me know how it goes. I'd be very curious to hear. The other thing I do want to mention that Linode let me know is they're also hiring. So if you go to linode.com/careers, if you're a viewer of the Coding Train, you probably have some of the skills that they're looking for in terms of their hiring as well. So feel free to check out their careers, apply for a job, and tell them that the Coding Train sent you. So I'm going to take just a couple-minute break to get a drink of water. And my iPad, oh no, it went down, so I don't have music to play. And so I would encourage you to go, if you have a few minutes, to try signing up at dashlane.com/codingtrain and linode.com/codingtrain. And both of those links are in this video's description with also a pinned comment that has those links as well. And I'll be right back to finish writing my code in about 5 minutes. I don't have any music to play, but I'm going to mute my microphone. So silence, meditate. Okay, I'm back. I had my little break. Sorry for this silence in the break. I'm going to charge this iPad up so that I can at least have the music or various sound effects for later. Where did I put the charger? It's so weird. I like had it a second ago in my. Oh, there it is. A longer cable would really go a long way right about now. But what can I do? All right. I'm still muted? No. Okay. Yeah, no, I'm not muted anymore. Okay, thank you. Choo-choo. All right, so I've got a little time. I'm going to finish making this example. I want to make 2 examples. So we'll see how this goes. All right. I'm just looking at the documentation, yeah. Okay. Ooh, I like this. Okay. Okay. Ah, this needs a semicolon! All right. I'm going to finally write some code in this particular tutorial. Now that I've gotten through that explanation, I'm here to write some code. All right. Okay, hold on. Let's take a minute here. Dan Man asks, and thank you, Goma Abora Tushio, and I'm so sad that I thought I set something up that if somebody does like a super chat message or whatever, it'll like appear as an overlay, but I really didn't do it right. But Dan asks, where can you get one of these? So guess what? It's taking me forever to do this, and it's very disappointing to me how long it's taking me to do this, but it is happening. I'm about to relaunch the members program on YouTube and make a bunch of changes, and I will be laser etching custom coding train whistles, which I will be sending out to new members. So anybody who's an existing member right now will get one. I'm going to send one to everyone, whether you joined a while ago. Well, not everyone, sorry. Anyone at the $10 level or higher, because it is kind of there's going to be a significant expense with buying these. Not that significant, but buying them, laser etching them, and shipping them. So I haven't figured out all the level stuff, but that is something that I will be sending out. I have some new stickers. I have like a member-only exclusive. It's not a thing I'm going to sell. It's going to be an exclusive coding train laser etched train whistle. I'm going to learn how to use the laser printer, by golly, to do that. All right. I like how Bruno writes, in the edited version, I'm maybe 50 seconds into the video. I'm like an hour and a half into here. Okay. That was Japanese yen, yes. All right. So that's coming. I mean, I think that I'm going to have that, I would say, in early 2020. That's my guess. So anyway, lots more. I'm launching a new store. I've mentioned this before, but huge thank you to Standard.tv, which is a company that works with a lot of wonderful other YouTube channels. And you can find all of the creator stores here, and I'm hopefully going to be here soon. They help me with the sponsorships. And they also have a service called Nebula that you should definitely check out. And there was something else about Standard that I want to say. Oh, these thumbnails, which I am absolutely in love with, were created by Simon, who's a designer who works with Standard.tv. So anyway, right, goodies for the Patreon subs. Yeah, so David Skeck, I don't want to, I got to get back to coding and stuff, and I don't want to, but my plan, I know that you want to stay through Patreon, which is absolutely fine. I am not going to delete the Patreon, but any goodies that are YouTube members, the goodies will be the same for YouTube members or Patreon subscribers. But there are a few things that YouTube will allow me to do in terms of member-only stuff that if you're on Patreon, you won't be able to get access to. But in terms of mailing something or any other rewards like invitation to Slack or Discord or whatever you use, and I did get GitHub sponsorships unlocked, so I might make GitHub sponsorships the preferred alternative to YouTube memberships if you don't want to be giving part of your funding money to Google, which frankly you are if you sign up through YouTube membership. They take quite a large percentage. You know, in my mind, it's a reasonable percentage. I'm getting a good service here, but okay. To the code. Now I got to log in. Shoot. Here's my Dashlane ad. I'm logging in through Dashlane, which is logging me into the web editor. And yeah, I want to leave this page. Okay. I'm starting with a P5. Okay, right. Now that I've gotten through that explanation, I really want to just write some code and show you how this all works. So I'm starting with a P5 sketch that also is referencing the ML5 library 0.4.2 as of today. But that's not the important part. I want to go back to my JavaScript file, and I have that here. So what is the code that I want to write? So I want to make a variable called model. So I'm going to call it, you could call it neural network or machine learning classifier thingy. I'm going to call it model. And my model is going to be a new ML5 neural network. So this is neural network is a function you can call in the ML5 library that creates an empty version of what is right here. And it's up to us to configure the inputs and the outputs. So one thing, and the way that you can do, there's a variety of ways you can do that, but I'm going to show you how to do that by creating a variable called options, which is just a JavaScript object that has the configuration for the neural network. And then the options gets passed in when you create the neural network. So the things that I want to do is I want to give it a certain number of inputs, in this case 2, a certain number of outputs, in this case 3, and then also I want to tell it what kind of task I want it to do, a classification. Super chat from Martin W. Thank you. Mwah. Team Trees, says Epic Picks. Team Trees. Super chat from I Understand. Thank you. I want those overlays. I'll have to figure that out for the next time. Incidentally, how do I know this is what I type in here? If I go to, whoops, not processing. If I go to the neural network documentation page on the ML5 website, all of this is documented here, and probably what's most useful is right here to show you this is exactly what I've done. The number of inputs, the number of outputs, and the, oh, it says type. I thought this is task. I think it's task. It does say type. That's weird. Let me look at the examples. I kind of think it should be task. Could be type. Task. I'm pretty sure it's task. I think that's an error in the documentation. Because my memory is that it's task. So I'm going to leave it as that. So I'm just going to. Incidentally, and I'll cover this in a future video, if your data is something that's in a file, you've already collected it, maybe it's in a JSON file or a comma-separated values file, a CSV file, you can actually load that file as part of what the neural network, and it will use that file to train the neural network. But I'll come back to that in a future example where I'll show you a scenario where that makes sense. In this case, there is no data yet. I'm going to collect the data in my P5.js sketch itself. In addition to another way that I can also create the neural network is instead of just specifying there are 2 inputs and 3 outputs, I can also give names to the inputs. This isn't something that a neural network needs or even uses, but it's a way that's very useful as a programmer creating the neural network for me to keep track of what's going on, to name my inputs and name my outputs. So that's actually the way that I want to do it in this particular example. So I'm going to change the number of inputs to an array of names. And the outputs, what did I say? I'm going to do the note C, D, and E. So this now is what it looks like with the inputs named. Instead of saying 2, I'm going to give it an array with 2 strings in it. Instead of saying 3, I'm going to give it an array with 3 strings in it. So many super chats going on. I will try to come back and thank them, or I need a way of keeping track of them. Good job. Keep it up, says Igor. Thank you, Igor. And there was also one from I Understand. Thank you, Nathan, for being the manual super chat. All right. Where are we now in terms of these steps? We're in the collect data step. I want to collect data. To do that, I'm going to make an array. I'll call it training data. And every time I press the mouse, I will collect a data point. So I'm going to create a variable called a sample. A sample meaning like one data record, one instance, one sort of slice of the data. And it's going to have an x value, which is going to be mouse x, a y value. Oh, wait a second. This is not how it works, is it? How does this work if I guess I say label. If I'm doing classification, I just call it label. Like when you're doing classification with, hold on, let me look at the documentation. Range. Oh. No, that's how it works there. Oh, let's. Oh, I don't actually give it the number. That's weird. It's funny, we went around in circles with this, and I think I'm forgetting how it works. Because the examples that I made didn't use classification. Does it figures out the number of labels? That doesn't make any sense. Hold on. Let me go to my examples from my class, because I have this example, and here. Yeah, this is the example that I'm intending to build. I can't use the computer. Why is this not changing? There we go. Okay. So what I want to do is change this to, okay. Pretty sure we added this support here. Oh, right. Sorry, everybody. Figuring this out. Stuff is hard. No, getting started. Copy to clipboard. Okay. Sketch. Let's see what happens. X is, so what I'm doing is, this doesn't make any sense how this would work with classification. Can I just do this? Maybe if I just do this. All right. Oh, I'm going to try it like this. And see. Oh, no. Let me see if this works. So I'm going to give it a bunch of A's, change it to B, give it a bunch of B's, train, A, B. Oh, so this is working. So that's how it works. You just give it the, all right, great. So it works the way, it's going to work the way I want it to work. Fine. I just had to understand what I was doing. Okay. Sample with an X that is mouse X and a Y that's mouse Y. Then I also need a target. A target is, because I'm collecting training data, I need to not just only collect the inputs, and actually, you know what? I'm gonna change it like this. Actually, let me call this inputs, because this is really what I'm doing. I'm collecting what the inputs should be for this training data. So the inputs are X is mouse X, Y is mouse Y, and then the output, I also need to have the output, which is some particular note that should be associated with this X and Y. But I'm going to actually call that a target, because this is training data. So in the end, oh boy, why did this go off? Oh dear, this camera is so off. In the end, I want the neural network to guess the note for me, but I have to give it some examples of what I want. So in this case, let's just say it's going to be C. And then I can add this data to the model. So I'm going to say model, add data, the inputs associated with this particular target. Then, just so I can see what's going on, I think I should save all of this. Training data. I guess I don't need to save it. I should just draw it here. I do want to. That's a way that's going to make sense. Oh, can I do that like object destructuring thing? I want to save all the data, so I'm going to use that array that I created earlier and say training data.push, and I'll make a new object that has the inputs and the target in it. And then in the draw loop, I can loop through everything. And visualize the data onto the canvas. Drawing a circle, and then also drawing the category for that, and then also drawing the class associated with that circle inside the circle. Let's run this and see if it works. Great. So as I click around, we're seeing all these data points that all have an XY associated with them and a label associated with them, in this case, hard-coded as C. Input provided is not supported, does not match your output label specifications. Now I am getting an error here which says that input provided is not supported or does not match your output label specifications. So I think I've made a mistake here. Let me see if I can figure out what that is. What did we say? 12:15. Neural network. Inputs, outputs, yeah. What did I just like pulled up? An example, yeah. This worked. What's different? Is it really type and not task? Did it change to type? No, this is using, oh yeah. Hold on, duplicate, let me save this. Reference, neural network. No. Getting started. Copy. This worked, right? Add data. Oh, I know what the problem is. I know what the problem is. The target has to be in an array because there can be multiple, in many cases there's multiple outputs. All right. Aha! I have found the error of my ways. Very common mistake. In this case, my target is the string C, the category C. I want to play, ultimately I want to hear the note C played. But in many cases, there could be multiple, especially in a regression problem. In many cases, and you'll see this in future examples that I'll demonstrate, there could be multiple outputs, whether it's multiple categories or multiple numbers. There's lots of possibilities here. And so just the outputs themselves, yeah, it really should be, there should be a different way of doing this. Need to be, but this is the way it is right now. The outputs themselves need to be in an array. So I needed to put this bracket here around target because I'm taking the category C, and that individual class in an array with one thing in it is the actual target that I want to give to this particular model. So let me run this again and see if that error goes away. I don't see that error anymore. Now I need some method by which I select what the training label is. And so I'm going to create a variable called target label, set that equal to C. I'm going to have a function called keyPressed, and I'm going to say training label equals the key that was pressed, console log training label. So I'm going to just do a quick and dirty interface, which is really no interface, to have the label set by when I press the key. And I'm not doing any error checking to make sure I'm just doing C, D, or E only, but all that could come. You could add that. And then the target should be that training label itself. And let me run this now. Training label, sorry, target label, not training label. CCC, let me press D. No, that didn't work. Oh, training label. It's called target label. And let me just make sure it's uppercase to be consistent. CCC. Target label. CCCCC. DDDDD. E. So I now have collected my data. What is the next step? The next step is train the model. And luckily for us, this is a very easy step for us to accomplish simply by calling a function in the ml5 neural network library called train. And yes, it is a train. So I'm going to add an extra function here that I'm going to check if the key happens to be pressed as T. Now I am going to call model.train. Now when I train the model, I also have some options that I can specify. And there are a variety of things, and I could sort of come back and talk about some of these terms and how they affect the process, maybe in one of my subsequent videos. But for right now, I'm going to just talk about one particular term, and that term is epochs. So I'm going to say epochs 10. I'm going to train it based on these options, and I'll come back and say, so what is epochs? So what is epochs? Look at this. Somehow, oh, something, control. How did that get in there? Oh, because I'm like typing keys all the time and then I click the mouse. I should validate it, but whatever. Oh, shoot. I just want to. CDE. All of these data points are going to be fed into the model as part of the training process, one at a time. The inputs along with the target. The inputs get fed in, the model makes a guess. If it's gotten it correct, moves on to the next one. It feeds the inputs in, the model makes a guess. If it's gotten it incorrect, adjusts all of these dials all over the place, these weights of the neural network, towards the error to try to correct that error, and then starts over again. It's feeding in all the data one at a time. So what is an epoch? An epoch is one cycle through every single data point fed into the model. So maybe there's 35 here. If I have 10 epochs, I'm feeding in all 35 data points. And of course, the camera's overheating. It's really not that hot in here. Turn this fan on. Move the air around a little bit. It's not the coding train if the cameras don't just shut off every once in a while. So if there are 35 XY target trios, so to speak, then, and I do 10 epochs, then it's doing all 35 of those 10 times or 350 training cycles through the neural network itself. Now, interestingly enough, and this is built into ML5, it shuffles the order of all of these randomly, because I collected all of the C's, then all of the D's, and then all of the E's, and the model wouldn't train very well if it didn't do that, but that's something that's built into ML5 itself. So I've set the epochs. I've set the epochs, and now the train function, it's something that's going to take some time and actually has multiple callbacks associated with it. Let me go to the page. Where does it send an error? I guess, who knows? Okay. Okay. There's a while training callback. And this is a function, an event that's triggered. This isn't a function, an event that's triggered at the end of every epoch. And then there's a finished training callback. And this is triggered just once. When the training process is complete. So let me write those functions. While training. Finished training. In finished training, I'm just going to add a console log. And the while training callback will be sent 2 arguments. One argument is what epoch are we on, and the other argument is a value called loss. Now, ultimately, I only need the while training callback if I want to sort of debug what's happening during the training process. So for the moment, I'm just going to console log the epoch. And I'm also going to add another property up here in the original options, which I'm going to set as debug true. Because often when you're training a machine learning model, you want to see a visualization of the training process and how it's going. And there is a particular library called tfviz. So ml5 is built on top of TensorFlow.js, and there is a visualization library associated with TensorFlow.js that will draw graphs and different things about the training process. So setting debug to true will make that happen automatically. And I'll show you exactly what I mean in a moment. It's possible that I've forgotten something, but I think I have all the pieces here. I have my options, which I want to train over 10 epochs. I have a while training callback, where I could just see every epoch one at a time in the console, and it'll tell me when I'm done. And I've turned debug on, so I should see a visualization. So let me move my screen around so that I can see all this stuff. Collect my data. And now for the moment of truth, I'm going to press the T key, and as soon as I press that, the training process should start. I should see the epochs being logged here and a visualization over there. Let's see what happens. Oh! I forgot some steps. I forgot some steps. I thought this would work anyway. I thought we fixed it so that it would work. Just like finished immediately. So there's an important function which I was going to demonstrate. Okay, yeah, it's supposed to work without this. I don't know why it didn't. That's annoying. I thought it works without this. Let me see here. Is there, if I don't want to normalize the data, is there like a, yeah, that's weird. So it's supposed to work. It's 12:30. Oi. Yeah, weird. So we had fixed it, I thought, so that you don't... I was going to talk about how normalizing is an important thing, but I guess I'll just... That's weird. Because I remember going through the source, and we added something that if you don't normalize it, it will finish preparing the data. But all right. Unfortunately, I missed an important step, and I meant to talk about this afterwards, but I think I need to talk about it now. So one of the things that's very typical of working with a machine learning model, in particular a neural network, a neural network-based machine learning model, one of the things that's very important about working with a machine learning model, in particular a neural network-based machine learning model, is the fact that data should be normalized before it's fed in as inputs into the system. And what do I mean by normalized? What I mean by normalized is take any arbitrary data, look and squish it or squash it or standardize it for all of the values to fit between some well-defined range. So in this case, if I have this canvas, and everything in the canvas is an XY point. Oh, you can't see that. In this case, if I have a canvas and everything is an X and Y point in the canvas, I'm getting values like 100 pixels by 100 pixels. But I want to normalize those pixel values into a number between 0 and 1. So if the width is 400 of the canvas, all I need to do is divide by 400. But ML5 has a utility in it that will normalize the data for you. It will just look at it, examine it, find the minimum, the maximum, and squish everything down to a value between 0 and 1. And to do that, all I need to do is add one more line of code right when I'm finished collecting the data or right before I'm about to train the model and say model.normalize data. Let's give this a try again. I'm going to collect data. Now I'm really going to train the model. And it's totally not working. What have I done wrong here? All right. Whoa. This is a fail. This would have been much easier if I hadn't bothered. This would have been a better way to demonstrate it, I guess. This should work. Oh, wait. Target label is this. Wait, what's going on? Inputs 2, outputs 3, classification, debug. Oh. The way I'm drawing it is different. Whoa. Why is everything always so hard? Well, that's promising. Is it just like, okay, that's good. Oh, yeah. 10 epochs is not enough? Should get like a really, really low loss. Let's try this example. Basically the same example. I really need to, I wanted to demonstrate how I could save and just reload the data so I don't have to do this each time, because it's kind of ridiculous what I'm doing here. But why is this like not? Yeah, this is what I expected to see. So this is working. 100 epochs. What did I mess up? X mouse Y. X Y. Output CD. Semicolon line 18. I don't think that's the problem. All right, let's see here. Try to make this very distinct. How many epochs did I put in there? 100. Give it a lot more data. It really should be able to do this with very little data, especially with a lot of epochs. Here we go. Okay, there we go. So amazingly, it's just so little data. I guess it needs a lot of epochs. And I should have given it even more because it's just so little data. Although I guess I could probably mess with the learning rate. I think it's called learning rate. I'm just curious. Maybe I'm 0.25. These are the defaults, but as soon as I do classification, no. Just curious. Hold on, let me save the, I'm going to actually save the data. Well, you know what? I'm actually just I'm going to leave it. Let me try this again with many, many more epochs. I'm realizing it's just very, very little data. So in order to make it seem like it's a lot more data, I can just increase the number of epochs. And I'm going to collect some data yet again. I'm going to show you how you can save the data to reload it so you don't have to keep collecting it over and over again if you're trying to debug your model. Very important thing. But I'm just going to collect it again. Press train. And very good. So what I'm seeing is exactly what I want to see. I want to see this graph of a line that's going down and down and down and down and down as low as it can go. Done. And we can see here in the console, these are all the epochs. It got up to epoch 199 and then said done. So what is it graphing over there? Camera has gone off. It's graphing a very important property that's part of it's graphing something called loss. Now we could actually look, you might recall, we could actually look right here in the while training function at the actual loss value itself. What the loss is, I lost my, I think once I get 2 hours in, I lose my ability to do this. Let me start this whole loss explanation in. Thank you, Simon. That's going to be useful in a moment if I could ever get to it. The graph is of the loss. Loss is a particular value, a measure, a metric of the training process. It's a summation of how many mistakes it's making as the training data is fed through the neural network. So again, remember the training process is take a particular data point, feed it through the network. It's going to make a guess, compare the guess to the correct answer. If it's the correct answer, guess what? The loss is 0. The error is 0. If it's not, it's going to be far or close to that error. And by accumulating all of the errors over one epoch, that value is summarized in loss. So as we can see, as it's training over time, the loss starts up at a value of 1.1, and it gets, and actually we can see here in the graph, at the very end, we were down to a loss of 0.073426, which is a pretty good loss. Anytime you see a value lower than 0.1 in these kinds of scenarios, it's doing particularly well. And you can see the graph is starting to level off. Maybe I could have eked out a little bit lower loss by giving it more epochs, but most likely that was good enough. Okay. Whoops. Finally, in this rather lengthy tutorial video, we are ready for the last stage, prediction. I have trained the model, and now it's time for me to give it new data, new XY coordinates, and have it guess a note, C, D, or E, based on that coordinate. And you may have noticed that as I was training the model, the data that I was giving it happened to be very distinct. I wanted to learn that when my mouse is over in this corner, play the note C. When my mouse is in that corner, play D, and towards the bottom, play E. But if I were to experiment with this a lot, it would be very interesting to train the model with a variety of distributions of how I collect this training data set. One thing I want to do here, an important feature to this example that I think I want to add now is having a sort of state. So what is the state? And I'm going to say the state at the beginning is collection. And so in this case, that's going to affect what happens. You're distracting me with your sharing of YouTube videos in the Slack channel. I'm going to use that state to determine what should happen in the mouse pressed function. So if the state is collection, add training data. Otherwise, if the state is prediction, make a guess. So I need to add the code for making a guess in a moment, but let's figure out how I'm going to sort of track this state over the course of the program. And I look forward to all of you who change this into a switch statement and share that with me in the comments. So as soon as I press the key T, the state should be training. And then once I'm finished training, the state should be prediction. At the prediction stage, I want to do the same thing. I want to take the inputs and send them into the neural network. But this time, I'm not giving it a target. There is no target. I just want the neural network's prediction or guess. And in this case, because it's a classification problem, I want its classification. I want to... And in this case, because it's a classification problem, the prediction is the label. I'm going to say model dot, and in this case, because it's a classification problem, my prediction is actually classify. I'm asking the model to classify. So I'm going to say classify these inputs, send those inputs into the model, and when you're finished, give me a result back. In a callback, so write the got results function. The got result function can take multiple arguments. Error, or results. If there's an error, do nothing. Otherwise, right now, let me just take a look at the results. This is really nuts that I've got to collect the data every time I do it. I'm definitely going to have to find a way around that, which I have one. I will demonstrate that soon, but I'm just going to collect it again. Training the model. Come on, Loss. You can do it. Now we are ready. Oh, it's just registering all my mouse clicks, so I should probably constrain it to only registering the mouse clicks on the canvas. But I'm going to click up here. I'm in the prediction stage. I'm going to click in the top left. And if I click in the top left around the cluster of the notes C, I should see that the highest confidence score classification it gives me back is the category C. Click. And it's this one here, the second one, object 0. Look at this. I'm so glad this worked. 98% confidence that that click registers a label of C. Let me click over here. 86% confidence the label E. So the results that come back in the results variable, in the got_result function are, this is the same as every other ML5 function that I've demonstrated to you, an ordered list of the labels sorted by confidence score. So there's always 3 possibilities, each with a confidence score, and it's always going to put in the array the highest confidence first. Because I'm over time, I'm checking my phone here. Okay, no emergency messages. This example is ultimately finished. I mean, there's been no thoughtfulness to the interface here or why it is you might want to make something like this. This is really a bit of my hello world introduction to that neural network function in ML5 itself. However, to make this feel at least like something that has some application to it, I want to add the feature that whenever I'm creating the training data, it plays the musical note as I click, and then when it's in the prediction stage, it once again plays its guess as a musical note when I click. So I'm not going to show you all the details of how this is coded here. I'm going to go grab code from one of my examples that uses the P5 sound library and an oscillator and the envelope class to play a musical note. And then I'm going to put that in this code and demonstrate it to you. So if I go to, let's see. The question is, what's the chance that I can find this code, the sound, P5JS, sound envelope. This is what I want. This is the code on GitHub for my sound envelope tutorial. So I'll link to that particular video if you want to watch it. But I'm just going to start grabbing this code and putting it in my ML5 neural network example. So where? Add data. Where's the mouse? Oh, haha, I'm adding it to the wrong example. I added it to the other example. Let me close this. Wrong example, goofball. It's like, why does this look so different? Let me actually capture this sound. Now you're getting the sound. I think I want this. This doesn't really sound. What is it? Attack, decay, sustain. Just change. I don't know. I want it to sound more like a piano note. Somebody could give me some set range 1.2 to 0. What does that do? Whatever. Someone could give me some better numbers to put in here. But now I want C, D, or E. So I need to get those frequencies. Yeah, that's a good idea, Simon. I will do that also. I'm waiting for like some good ASDR values to do the next part. Modify other sound. Okay, no, I don't really need it to sound like a piano. I just sounds kind of like. I want it to be a quick note. This is what I want. Like this. Oh, that's the decay. I guess I should just go back to whatever I had it from my example. All right, perfect. All right. This is not important to this tutorial, so I'm just going to move on. Now that I've added an envelope and an oscillator, I just call the play function every time I click the mouse, and you can hear a note being played. But I want to play a C, a D, or an E, so I need to get the exact frequencies for those particular notes that I want to play. I can grab them from this Wikipedia page for piano notes, and I'll get middle C, D4, and E4. I'm going to make an object that just has those values. And so this is my lookup table. Based on whatever category it is, I want to set the wave to that particular frequency. So right before I play the envelope, wave, frequency, frequencies based on the target. Let's see if this works. C. And now it's playing C, D, or E based on when I click. Now I can pull the note, which is the label associated with the first result, since it's a sorted list, and I can set the frequency based on that note and play the envelope again. And probably it would be good for me to also draw it, but I'll leave that to you to make a much nicer interface for this. And I'm just gonna finish this off by collecting the data one more time and then having it play the notes as I click around. And this time, maybe I'll give it a bit more of an odd. This time, maybe I will give it a bit more of a less obvious or sort of uniformly distinct spatial arrangement of the training data. Here we go, training data time. There's my data, train the model. I don't know if that control that got in there is going to break it. We'll find out. Train the model. So I'm reading the chat now. I do sometimes read the chat. Don't overfit, yeah. And now, let's see what happens. Oh, wait. Huh? Oh. What did I forget? Do I have an error because of that weird? Oh, freak was not defined. Oh no. Oh no. Oh, this was a, oh no! All of that work, and I forgot the S there. Let me fix that and do it again. Oh. Oh, P5, oh. Oops, I didn't realize this, but it's actually called, I should call it P5 envelope, not ENV. Train the model. All right, finished training, and now, in theory, it should do prediction. Let me zoom in so you can see this a little better. Look, it's even giving me a C note here. That's its best prediction based on all the C's up there. It'd be really interesting to visualize every sort of like what the value would be for every pixel. That's something you should do as an exercise. So imagine, even though this is kind of an obvious and almost trivial scenario, imagine if you were using your hands and maybe you had now this is an obvious and somewhat trivial scenario, but imagine expanding on this. Imagine having many more notes. Imagine having the inputs not just be a single mouse click, but perhaps an XY of you're tracking your hand, maybe with the PoseNet feature of ML5. Maybe you're tracking two hands, so you're actually training the model to learn based on 4 inputs, your entire pose. I'm going to get to that. So, and then you have a lot more notes than just 3. You could imagine how you could expand this to start playing a musical instrument based on how you move your body. And this is the sort of seeds of that idea in this very basic example. There are a lot of missing pieces to this example, and so the 2 things that it's really 3 things. The things that I want to demonstrate, and I'll do a follow-up video where I will add these features in, is 1, I would really like to be able to, save the model I trained, so I could just load it back in another sketch. I don't have to go through training it again. That's quite possible to do. I also might want to just save the data set. Like maybe I don't want to save the model, but I want to save the data set because I want to try training it again, but with slightly different parameters. I haven't really showed you what are the kinds of hyperparameters you can change for training the model, but there are some. So I want to show you saving the data, saving the model, and also what if I wanted to make this a regression instead? So right now it is always playing a very specific note, only one of 3 possible notes. But what if what I wanted to do when I clicked over here, I wanted to hear an interpolation of what its sort of guess would be, in this case kind of like somewhere between C and D probably. I'm about halfway in between those clusters. So what note would it play if it was returning an actual floating point frequency value? And this actually would be very easy for me to adjust this example. mostly all I need to do is change this term from classification to regression and then change the way I read the output. But I'm going to still do that in a separate video follow-up that will come after this. So maybe try that on your own and then see what happens in the video that it might not be released right now if you're at the time you're watching this, but hopefully it is. All right, thanks for watching, and I'll see you in the next ML5JS Beginner's Guide to Machine Learning video. Okay, boy, that took me all this time just to make this one video tutorial. I don't know. I don't know what the sort of general audience is of all of you, according to my stream deck here, 382 of you watching. If this was illuminating or interesting at all, I would certainly be curious for feedback. I wonder. So I think I probably got to head out. I'm about 45 minutes later. I do kind of want to I would love to just rapid fire fill in those next two steps, but I don't know that I really have time for that. Are there any questions I could answer that anybody has? Okay, good. But you're giving me nice feedback, which I appreciate. Epic Picks is, oh yeah, so if you want this, the nice thing is you can get this example right now. So if you want to run this particular example, it's at this URL. Maybe somebody could post that into the chat. Sorry, somebody who has chat privileges could do that. Oh, can I do that? No, not easily. Do I have red in my beard? No, but I have gray. Could you do this with the makey? Yes, that would be a wonderful thing to think about. What other kinds of inputs could you have that are like sensor inputs? So I don't know when I'll be back next. Oh, I can tease something. Next Friday I have a guest coming. And the guest, I should just say who it is Shirley Wu, who is a data visualization artist. She's going to do a D3 tutorial. So maybe I can find some time before next Friday to come back and finish doing this example. So Fluke asked a great question. What is this building towards? What does this have to do going? Thank you, Solar Liner Nathan, for posting the link to the code. So I'm building towards maybe something that would be a musical instrument that you play with your body. So ultimately, the example that I want to make is I'm taking, the training data is I'm collecting different poses. Like when I stand like this, it's the musical note C. When I stand like this, it's the musical note D. When I stand like this, it's the musical note E. And so then I want to play a song by doing this. That's what I'm building towards, actually. All right. Oh, I don't have. I can plug back. This iPad is charging a little bit. And oh, not now. Come on, iPad. It's very important that I have music to play as I go. Leave. Why is this? I feel like I used to be able to do this stuff much faster. So Harshal asks, I'm doing a master's thesis on ML and I need some help. May I mail you? So I get a lot of email. And I very much appreciate all the emails I get, and I do read them all. It's very hard for me to answer coding questions. I try to prioritize the sort of students who are students at NYU who are taking classes. And then we also have, if you're a member, a Slack channel where people can get help with questions. You're welcome to email me but I don't have a good system. I would recommend more posting on a forum. Maybe we could create the Coding Train Discord. that sort of stuff. So close to 1 million, I know. At this pace, I think I'll hit, I mean, who knows, maybe it will go down from here, but I think I would hit 1 million subscribers in about 4 or 5 months. So I should plan something special for that. Okay, so I was trying to get this to play my, I don't know why it won't, but it's like everything's messed up right now with my tablet here. I can't get it. I just wanted to play my, I should read you some random numbers. I'll read some random numbers. 2.067, oh no. 74,831. Oh wait, today's coding train, which really was brought to you by Dashlane, dashlane.com/codingtrain, and Linode.com/codingtrain. You can get a free month from Dashlane, and you can get a free $20 in credit from Linode, as well as a discount with Dashlane. But also, today's coding train is brought to you by the random numbers, 74,831 and 56,110. Also, the random numbers, 81,963, 7,583, and 16,473. Also, the numbers 9,624 and 18,918. Okay, goodbye everybody. I will try to answer any questions if I can, but I'm moving to the wallpaper stage, and I will see you all soon. Next week, next Friday for sure, but maybe sooner. Maybe sooner if I can find some time. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget the this dot, this dot, this dot, this dot, this dot song. This dot, this dot. This dot, never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me.